Chapter 2, Exercise 21. Hints. For part A, assume the contrary and derive a contradiction based on the assumption that A and B are separated. For part B, prove that the set here is connected using theorem 247. For part C, assume the contrary and derive a contradiction using definition 217. Solution. A. Assume that A0 and B0 are not separated. Without loss of generality, we may assume that this. Consider a point T0, element of this. Define C equaling this. Then, C element of B. Consider any epsilon greater than 0 and let delta equal this. Note that absolute value A minus B does not equal 0 since A and B are separated. Since T0 element of A0 bar, there exists a point T in A0 such that this. Then we have this. Thus, P of T element of this. Since every neighborhood of C intersects A, it follows that C element of A bar. Consequently, C element of this, which is a contradiction. This contradiction shows that A0 and B0 are separated. B. Now we verify that the set 0, 1 is connected subset of R. Let xy element of this with x less than z less than y. Then this, implying that z is an element of this. By theorem 247, the set 0, 1 is connected. From part A, it follows that the sets here and here are separated. Indeed, since this, theorem 227c implies that this, and similarly this. Now this, and analogously this, showing that this and that are separated. Also, both sets are non-empty since P of 0 equals A element of A and P of 1 equals B element of B, which means this and this. Consequently, due to connectedness, this. And consequently, there exists a point T0 in 0, 1 such that this. In other words, this. C. Let E be a convex subset of Rk. Assume that E is not connected. Then there exist non-empty separated sets A and B such that E equals A union B. Fix points A element of A and B element of B. By point B, there exists T element of this such that this, contradicting the definition of a convex set. Here is a picture. Two separated sets A and B and a segment joining points A element of A and B element of B. Comments. Theorem 247 characterizes all connected subsets of the real line. The only connected subsets of R are this, where A be element of R with A less than or equal to B. This exercise provides additional examples of connected sets in Euclidean spaces Rk. Every convex subset of Rk is connected. For fixed points A, B in Rk, the set I equaling this is called the segment joining A and B. This exercise shows that every segment I in Rk is connected. In fact, every segment I in Rk is convex. For any 2 points, this, with Ts element of this, and for any lambda in this, we have the following, since this. Thanks for watching.